Hi guys, welcome back. Here I am again. Um, so let's take a look at a little bit at what we're going to do today. So we're still talking about systems of equations, but today what we're going to do is we're going to be really focused on word problems and how does our prior knowledge help us to solve systems of equations with using word problems. So whereas yesterday we looked at a lot of elimination type problems, today what we're going to do is we're going to, sorry, not elimination, substitution. So we're substituting one equation into the other. Today what we're going to do is going to be a little different. Today we're going to look at another method that you did last year with your teachers called elimination. Okay, so let's kind of talk a little bit about what I'm going to do is I'm going to pick a couple of questions that I want you to kind of look at of us to do together, and then the rest will be for homework. And again, the keys will be online so you guys can always check. All right, so a lot of this also involves a lot of prior knowledge in terms of translating from word into expression or from word into equation. So um, make sure that you guys are kind of remembering what you did last year as we work through this. So let's take a look at this first question together here. Okay, so the sum of two numbers. So there's certain things you have to always keep in mind. Like important words are sum, product, um, difference, because they're telling you that there's something going on between two or more numbers, right? So the sum is the answer to an addition. So you know there's going to be an addition happening. The sum of two numbers is 36. The difference, here's another important word, is 24. Find the numbers. Okay, so now what I want to do is I want to make sure um, that I am calling the number something. So I know that there's going to be two numbers. Let's say the first number is x and the second number is y. What do I know about them? When I know their sum is always equals, right? 36, and I know their difference. Oops, is y. Their difference is 24. Okay, so now when I look at this, I have two equations here. I want to practice, I want to kind of talk a little bit about why this would be nice, a good solution, a good way to solve this. I'm looking at these two equations here, and what I can do is I can actually try to combine them. If I could somehow, so what you want to do is, and this is what we do with substitution and with elimination, you always want to end up with one variable. You only want to work with one variable. So when you have equations that have two unknowns, you want to try to use a technique to try to get rid of one of the variables. When I'm looking at these two equations here, I notice that if I combine these two equations, so if I put them together, and what I mean by that is you're looking at the variables, right? So it's an addition really is what it is. You're taking one equation and you're adding it to the other one. When I do that, or when I combine them, I notice that positive y and negative y will cancel out, right? When I add a positive one and negative one, it's just going to be 0. So then that's nice because it leaves me just the x's. But again, you're combining, so it's really like an addition. X and x will give you what? 2x. And I also have to do the same thing with the numerical values here, right? So 36 and 24 will give me 60. Now it's a nice equation because I only have one variable that I need to solve for, right? And that's really simple. Divide by 2, and x will be 30. So I want to find the numbers. That's x. How do I find y? Well, then I can use either one of these equations to help me find y. It doesn't really matter which one. If I use x plus y equals 36, I know what x is. I know x is 30. So then what will be the value of y? I subtract 30 from both sides, y will have to be 6. And there's my two numbers, right? The two numbers are going to be 6 and 30. All right, so when you see something like this, you want to get rid of, think of eliminate, it's called elimination because you're eliminating one of the variables, okay, to make your life a little easier. All right, why don't you guys go to the back there and go to number 5. Let's do this one together. This is a nice example. Okay, so question says, At lunch, at the lunch counter, 3 pretzels and 1 cup of soda cost $2.75, and 2 pretzels and 1 cup of soda cost $2. Find the cost of 1 pretzel and 1 cup of soda. All right, so I know that I'm going to be going to be writing some type of equation. So I have to translate from what's written here into an equation. So what are we looking for here? We're looking for the cost of 1 pretzel and the cost of 1 cup of soda, right? So I want to make sure, and this is good technique, algebraic technique, I want to make sure that whatever variable I use, that I explain what it means, what it represents. So let's say, like, what you want to do is you want to pick a variable that reminds you of what it's representing. So let's say that let's let P equals the cost of 1 pretzel. Right? It's not 1 pretzel. It's the cost of 1 pretzel, because that's what I want to find, right? And let's call S. So S, we'll say that's the cost of 1 soda, of 1 cup of soda. Now that I have my variables and I know what they represent, I can start writing some equations. So what are the equations here? I know that 3 pretzels and 1 cup of soda cost that much. So if I buy 3 pretzels, so 3 pretzels times the cost of 1 pretzel, right? So 3P plus 1 cup of soda, 1S, or S, equals 275. There's my first equation. 3 times the cost of 1 times the cost of 1. Okay? And then what else do I know? I know 2 pretzels and 1 cup of soda is $2. So now if I buy 2 pretzels, 2 times the cost of 1 pretzel, plus, this is 1, okay, plus 1 cup of soda, well, then that's going to cost me $2. Okay? Make sense? All right, now, how do I deal? So now it's the same idea from before, but it looks a little different because the equations are a little bit more intricate, but it's the same procedure, right? I have 2 variables, I only want 1. So what I want to do is I want to take a look at these guys and see how I can play with them algebraically a little bit, so then I can eliminate one of the variables, elimination, right? So I notice that I have a 1s and a positive 1s and a positive 1s. They're not going to, I have to work with them a little bit, because for them to cancel out or to equal 0, they have to be different signs, positive and a negative, right? So in order to do that, then I need to make one of these equations. I have to multiply the whole equation by negative 1. Because then what does that look like? What's that going to look like? Well, it's going to look, now the top stays the same, plus S, or 1S, equals 275. But the bottom is now going to be what? Negative 2P minus S, negative S, or negative 1S, equals negative 2. Now I'm looking at these 2 equations, and I see now that I can combine these 2 and they go away. So what am I left with? Well, let's see. What's 3P minus 2P? Oh, so sorry, guys. So it's probably really loud on your end. I apologize. And so now 3P and 2P, so then I'm left with 1P, or just P. P will be equal to, and 275 minus 2 is going to be 75 cents. Awesome. So I know now the cost of 1 pretzel. 1 pretzel costs 75 cents. How do I find the cost of 1 soda? Then just like what we did before, we're going to substitute back into any equation, it doesn't matter which one, to get the cost of the soda. So go back to the original equations. How about we substitute back into this one? Right? So, and it doesn't really matter which one you plug it in, either the top or the bottom, it won't make a difference. So let's plug it back in. So we have 2 times P, which we know is 75, plus Y equals $2. Okay, so then I have what? 50 plus Y is $2 minus 150 on both sides, and then we're left with y equals 50 cents. Oh, sorry, this should have been S. This should have been S. My apologies. This S. Okay, so now I'm done because now I know the cost of the pretzel and I know the cost of the soda. Okay, so now sometimes you have to work with them algebraically a little bit to kind of help you out. Remember, you want to get rid of one of the variables. Okay, go to the next page. Let's jump to number 10. This is a good example to kind of run by you guys. Okay, so question says, the total attendance at a benefit concert was 425. So that's the total number of people that attended. The tickets for children under 12 were $250 each, and the tickets for adults were $375 each. The total receipts were $1,125. How many tickets of each kind were sold? Okay, so now we're looking for the number of tickets, not the cost, but the number of the tickets. How many adults and how many children? So I'm going to let C equals the number of children tickets, right? Or tickets sold to children. And I'm going to let, let's see, A equals the number of adults tickets sold or the number of adults that attended. Okay? So now let's go back up here and see what we know. What do we know? They're telling us that the total receipts, so the total amount of money that they made from the sales were $1,125. So let's think about how they got that. How did they get that? Well, they knew that so let's think about the children, the total for the kids. So I know that each of the kids, their tickets is $2.50 each, right? So to get the total amount of money sold that was made by selling tickets to the children is $250 times the number of kids that went. That's the total amount made by just selling children tickets, right? Plus, how many did they make for the adults? Well, the adults were $3.75 each, the tickets, and then we're going to multiply that by how many adults went. So that's how they made that money, right? So let's stop and see if we understand. It's the cost of one child admittance, one ticket for a kid, times the number of kids that went, and then the cost of one adult ticket times the number of adults that went. Okay, so now we know that. And what else do we know? They also told us this, right? Didn't they tell us how many total people went to the concert? So the total attendance, what does that mean? That means combining both of them. So in the number of children plus the number of adults is 425. Okay, make sense? So now we're left with the same kind of idea, right? We have two equations here, and I want to get rid of one of the variables. All right, so how do I do that? Well, let's work with this on the bottom because I feel like this is going to be easier to work with. So what I want to do is I want one of them to be positive, the other to be negative, and they have to have the same coefficient. That's the only way that I'm going to get 0, right? So if I look at this and I think, okay, well, what if I multiply the bottom equation here by negative 3.75? What would happen then? Well, then this would turn into negative 3.75a. Then I can get rid of that variable there. Okay, so I'm going to go ahead and try to do that. All right, so let's rewrite this. This is going to be the same as what? So let's go ahead and do that. So it's 250c plus 375a equals 1125. And then when I multiply this, don't forget to multiply, you have to distribute, right? Everything gets multiplied by that. So I'm left with negative 375c negative 375a equals negative 1593.75. Sorry, guys, I'm running a little short on room there. So it's negative 1593.75. Okay, so that's what I'm left with here on the bottom. Now let's see if we can what we can um, which variable is going to go away now. So we have positive 3.75a and negative 3.75a. So these guys are out, right? And now we're combining everything else. So 250c minus 375c will be what? Will be negative 1.25c. And this is gone, and that's equal to, so what happens when I combine 1125 and negative 1593.75? My graphing calculator, plug it in, and I get negative 468.75. All right? Now I'm solving for c, so I'm going to divide both sides by negative 1.25. So now I'm left with 375. Nice number there. So that's the number of kids that attended. How many adults attended? Because I want each kind, right? So then I have to come back up here and pick one of these equations to solve for a. Which one do you think will work? Well, obviously the guy in the bottom will be the nice one, right? So then I'm going to come back here, and I'm going to say, okay, well, 375 plus a is 425. Subtract 375 from both sides, and I'm left with 50. So that's how many adults attended, and that is how many children attended. Right? So it's pretty much the same procedure. You just have to know how to rewrite the equation, or write the equations, and then how to work with that. Okay? Make sense? Let's jump to, I want to do one more with you guys, and then I'll let you practice. Let's jump to number 13. Okay, so the question says, Mr. Mannery invested $21,000. Part of his money was invested at 8% and the rest at 6%. If the total annual income from both investments were equal, find the amount invested at each rate. Okay, so let's think about what we're dealing with. So you want to find the amount invested at each rate. So let's pick some variables here. Let's see. How about we call x? So let's let x equals the amount invested at 8%. Okay? And then let's let y equals the amount invested at 6%. So now we have x and y. So it's the amount of money, right? X and y are dollar amounts. So this is dollar and this is dollar. So let's go back up and see what we know. We know that he invested 21,000 in total. So the combination of these two amounts has to be 21, right? 21,000. So x plus y has to be 21,000 because that's the two amounts that he invested there, right? So part of the investment was at 8%. So we said x is the amount that he invested at 8%. So and the y is the amount that he invested at 6%. So how the total annual income is how much you're going to get at the end of the year after you invest. So how much money will you get if you invest your money at 8%? So if I invest this money at 8%, what I'm doing is I am taking the total amount of money and I'm multiplying it by 8%. That's going to give me the yield, or how much money I'm going to get. So I'm taking this and I'm multiplying by 8%. Always turn it to a decimal. If you don't remember how to do that, take the number and percent means out of 100. So just make a ratio, 8 out of 100, and it's going to be 8.08. So I know that that's the annual income. When I invest at 8%, I'm going to get this is the amount of money times 8%. And I know that that is actually equal to the amount of money I invest, but not at 8%, at 6%. Right? So these two amounts, the total incomes happen to be the same at the end of the year. Right? So let me just write this in a more algebraic way. So x plus y is 21, and then 0.08x equals 0.06y. And again, we're left with a system of equations, and I want to solve it algebraically. I don't want to graph it. I want to solve it algebraically. So how do we do that? Well, let's look and see. How would I do that? Just like what we did before, we want to try to isolate. Or we want to solve one in terms of the other. So the question is, what would be the best? What would be the best way to do this? So this is where we're hitting about what you guys think might be the best thing to do. So what have we looked at so far? We've looked at substitution, and we've looked at um, elimination. So far we've done a couple of elimination ones, but now I'm looking at this, and the equations um, don't really match up very nicely, because here I guess I could have x and y come here, but then what would I need to multiply one by to make it look like the other? It gets a little messy, right? So if I move this guy over here and I set it equal to 0, then what can I multiply this by to make it look like that? It's going to be kind of messy, right? It's going to be kind of hard to find the factor that's going to make two of them look the same, two of the variables, right? So what I'm going to do is I'm going to decide, I'm going to try substitution. I'm going to substitute one back into the other. So I'm going to take this guy here. I'm going to say, okay, let's divide him. Let's isolate the x. So I'm going to divide by 0.08 and 0.08. So x will be 0.06 divided by 0.08. So it's going to be 0.75. Y. Now this is going to be nice, because all I need to do now is plug it back in here. See how that works? So let's go ahead and let me show you here, because I have a little more room. So what would that look like? That's going to be 0.75y plus y equals 21,000. So there's a 1 in front here. Common terms, 1.75y is 21,000. And then I divide each side by 1.75. And I'm left with 12,000. So that is what? That's the investment at 6%. How do I find y? Or the x, sorry, how much I invested at 8%. Then I plug this back into the one of the two equations. Obviously, this guy's going to be the best one, right? So if I do x plus 12,000, that has to be equal 21, right? Because the combination of both investments was 21. Subtract by 12,000, and I'm left with my x. Okay? So then I'm left with 9,000, and that's the other investment. Okay, guys? So what I want you guys to do is I want you to work on all the other ones that we haven't worked on yet, that we didn't touch upon in class, and then you can always check. I'm going to put the key up online, so you can always check to see if you're doing okay. All right? Okay, guys, so I'll see you next lesson. Bye.